So hello everyone, I am Shaina Denji Sandigan, and today I will report to you the theorem 6.2 and 6.3, number 3. So before we start, let me introduce to you the homomorphism, which can be used later on. So it defined as, if we let G and star and H and X is the representation of multiplication, be two groups, so define a mapping of phi of G map H. So the phi is homomorphism if the phi of x star y is equal to the phi of x times the phi of y. So in theorem 6.2, suppose that phi is an isomorphism from a group G into a group G bar, then for any elements A and B in G, A and B commute if and only if phi of A and phi of B commute. So let A and B commute, then AB is equal to BA. So the phi of A and the phi of B is also an element of G bar. Now, the phi of A and the phi of B, from the definition from a while ago, the homomorphism, is also equal to phi of AB. Then, the commutative property lang nato, which is also equal to the phi of B and A, which is also, then we can conclude, since nabalik naman, so we can conclude that phi of B and phi of A is also equal. So therefore, the phi of A and the phi of B is commutative. So conversely, let phi of A and let phi of B commute. Then the phi of A and the phi of B is also equal to the phi of B and the phi of A. So ato na siyang napakita kaganina. So thus the phi of A which is also equal to the phi of BA, pakitagya pa na to kanina, hence AB is equal to BA. Now we can say A and B also commute. Therefore, A and B commute if and only if phi of A and phi of B commute. So now let's proceed in theorem 6.3. Suppose phi is an isomorphism from a group G to a group G bar, then G is a cyclic if and only if G is acyclic. So suppose that G is acyclic, then G is equal to G, where G is generated by the generator G of G. So any x of G is of the form. So we can say that x is equal to j to the power of k for some integer k. So, okay, next is, so we know order G is equal to order phi of G from the definition, since cyclic man siya. So if phi is isomorphism, then the order of G, which is the image, and the order of phi of G, which is also the pre-image, must be equal. So again, we can say that the phi of x is equal to the phi of j to the power of k for some integer k is also equal to the phi of g the power of k. So kana i-manipulate lang ibang butang asterisk para mas ma-emphasize. Now, let G be an arbitrary element of G, since phi is an isomorphism from G to G. So there exists some y in such that phi of y is also equal to G, but y is also equal to the G to the power of n for some integer n. So manay ang consequences. So as we saw above, p of y is equal to the p of gn, which is also equal to the phi of gn, because when phi is isomorphism, so makaget taog phi, then to phi of g to the power of n. So G is also equal to the phi of Gn, which is also equal to T to the power of n. So where T is equal to phi of G, which is the generator of G. So atong manotice nga as basing mga tanan masa nagikan ng T of the power of n, na-replace na siya gikan na siya, gi-replace na siya sa phi of G. So ang phi of G na-replace sa T. Wala siya, iyang gibutang phi, where T is equal to phi of G, is the generator of G. Thus G is equal to T, which is also equal to P of G. Hence, G is cyclic. So, similarly, for the converse, consider the math C is equal to the inverse of phi. So, basta matingala, maasan ako na nakuha. Notation na siya, guys. Ay, magkalibog. Okay. Then, C is the function of G. Then, G is an isomorphism. And G is a cyclic. So, since cyclic naman si G, we can conclude nga na siya ay equivalent nga G, which wherein G is a generator of G. So let G belongs to G be an arbitrary element, and since C is an isomorphism, so there exists X in G such that C of X is equal to G. So now X belongs to G, X element of G man, diba? So, as we have supposed ganina nga G is cyclic, so this implies that X is equal to G to the power of A for some integer A. Thus, C, G to the power of A is equal to C of X, which is also equal to G. Then we can say that C of G, the power of A, is equal to G. Let the C of G equal to Y. Then YA is also equal to G, which G is an element of G. Hence, G is equal to YA, where Y is equal to C of G, which is a generator of G. Then G is a cyclic since we found a generator of G in the form of C, which is also a generator of G. So that's it. That's the end of the presentation. Thank you.